So you've definitely heard the names, right? GPT-4, Mixtral. But there's this clever trick working behind the scenes, the thing that makes them so powerful and, surprisingly, so efficient. It's called Mixture of Experts, MoE for short. And believe me, it is completely changing how the most advanced AI is built.
So why is this MoE thing such a big deal? Well, to really get it, you've got to understand the massive wall the entire AI industry was slamming into. For years, the philosophy was super simple. Just make it bigger. But that whole bigger is better approach was hitting a very real, very, very expensive limit. The amount of money and energy it took to train and run these massive models was just getting out of hand. And I'm not kidding when I say out of hand. Just look at this number. Since 2012, the raw computing power needed for top-of-the-line AI training has exploded by a factor of 10 to the 21st power. I mean, a growth curve like that isn't sustainable. It's a dead end. Something had to change.
This whole problem even has a name. The computational scaling wall. See, the old way of doing things used what we call dense models. Now, in a dense model, every single parameter, you can kind of think of them as tiny little neurons in the AI's brain, has to fire up for every single calculation. So it doesn't matter if you're asking it to write an epic poem or just translate one word. The entire colossal brain lights up. It is just wildly inefficient.
Okay, so how do you smash through that wall? Well, the answer is just so elegant. Instead of building one giant brain that tries to be an expert in everything all at once, what if you built a team of specialists? And then for any given problem, you only call in the exact experts you need for that specific job. That right there, that's the genius behind Mixture of Experts.
And this slide just lays it out perfectly. Over on the left, you've got the old-school dense model. Think of it like a generalist, a jack of all trades that uses all of its brain power for every little thought. But on the right, that's the MoE model. It's a team of specialists, and it's managed by a really smart, well, a router. The router looks at a problem and basically says, okay, this one looks like it's about history and poetry. You two, you're up.
The fancy technical term for all this magic is conditional computation. This is the key. It means a model can have a truly massive number of parameters, a huge library of knowledge, but it only uses a tiny specific fraction of them for any single question. And what that does is it completely separates the model's total size from its actual running cost. That is the breakthrough.
Okay, so the big picture makes sense, right? A team of specialists, but how does it actually work? Like, how does the system know which experts to call on? Well, it all comes down to that brilliant manager we talked about, a little piece of the puzzle called the gating network, or, just the router. So here's the play-by-play. It all starts when a tiny piece of data, in the AI world we call it a token, hits the system. Instantly, that router analyzes it and acts like a dispatcher, picking just the best handful of experts for that specific task. Then, those experts get to work on the token at the same time, in parallel, and finally, their individual answers are all blended together to create the final output. It's like a super efficient assembly line for thinking.
Now let's use some real numbers, because this is where it gets crazy. Take Mixtral 8x7b, a really popular open source model. It has a total of 46.7 billion parameters. That's huge. But its router only ever picks 2 of its 8 experts for any given task. That means at any one time, it's only using about 13 billion parameters. Just think about that. You get the knowledge of a nearly 50 billion parameter model, but you get the speed of a much smaller 13 billion parameter model. It is literally the best of both worlds.
And this isn't just theory, something cool on a whiteboard. This efficiency leads to massive, measurable wins out in the real world. Let's take a look at the proof.
This table really gives you a sense of the scale we're talking about. Look at DeepSeek V2. It has an absolutely mind-boggling 236 billion total parameters. But because it's an MoE model, it only ever uses 21 billion of them at a time. It's like having access to the entire Library of Congress, but a genius librarian instantly materializes and hands you the 2 exact books you need.
So what do you get for all this clever engineering? Speed. Pure, unadulterated speed. This chart is just wild. It puts the MoE model, Mixtral, up against a much bigger dense model, Llama 2 70B. And what happens? Mixtral is an incredible 6 times faster. If you're building an app on top of this stuff, that is a night and day difference in how it feels and what it costs to run.
And the wins don't stop with just speed. It's also about the cost to even build these things in the first place. Training these models is notoriously expensive. But check this out. By using an MoE setup, the team behind DeepSeek V2 cut their training compute needs by 42.5%
compared to what a dense version would have cost. We're talking millions of dollars in savings, not to mention a much smaller carbon footprint.
And don't think for a second that this team of specialist idea is only for language. Not at all. It's a fundamental principle that you can apply everywhere. For computer vision, you can have an expert that's great at recognizing faces and another one for identifying landscapes. In multimodal AI, you can have separate experts for text, images, and sound, all working together. The flexibility here is just incredible.
So, all of this brings us to what's coming next. Because mixture of experts isn't the end of the story. It's really just the first chapter in a whole new book on AI development. The innovation is happening at a blistering pace, and one thing is becoming super clear. The future of AI is sparse.
I mean, researchers are constantly pushing things forward. They're building these cool hybrid models that mix an always-on generalist with a bunch of on-demand specialists. They're making the routers smarter, more stable. We're seeing models like DeepSeek v3 that don't just have 8 experts, they have hundreds for extreme specialization. They're even finding these clever new tricks to balance the workload, so every expert stays busy and efficient.
And this quote right here, it just perfectly sums up the new reality. The cutting edge of AI isn't just about raw, brute force scale anymore. The really big breakthroughs are coming from smart systems design, from making the hardware and the software work together in perfect harmony. It's all about working smarter, not just bigger.
And that leaves us with one final, pretty exciting question. The mixture of experts idea has basically shattered that computational scaling wall, making AI way more powerful, more efficient, and honestly more accessible than we ever thought it could be. So, with these incredible new tools, what problems are we going to solve next? The kind of problems we used to think were impossible. The future is wide open.